As part of the resource section for my DCG portfolio number 2, which is the topic of surface geometry, I have created this resource that can be used for both discovering the dihedral angle between two surfaces and also the section of roof geometry. This model can be used for the dihedral angle, as the pupils will be able to physically engage with how to determine the angle using both the point view method, where we firstly look down the surface as a point view, and this will give us our dihedral angle. We can also use the rebattement method, which involves inserting a plane 90 degrees to both this plane and this plane, which will give us a triangle, and folding that triangle down flat 90 degrees, where we will look straight down on it, where if we move our two planes out of the way, we will be able to determine the dihedral angle which will be created on our plan view. This model can also be used then for roof geometry, as the two topics cross over. As can be seen, this is a section of a roof which can be used then to determine the dihedral angle. For the roof geometry, we can use this to demonstrate the true shape of a surface and how in different views that we see foreshortened measurements. So generally we are given the plan view like so, and we're given the elevation, and in both these views our surfaces are foreshortened. Although in elevation we can get the true angle of this surface here, because we are looking perpendicular, because our base plane is at 90 degrees like so, because it is a square piece of timber. If that was to be an irregular shape in the form of a pentagon possibly, or not at 90 degrees, it would leave that what we'd actually be seeing would be a foreshortened view of this, because it would be at an angle like so. What we can do to demonstrate the true shape is show how with rebattement, or else the auxiliary method, but for instance rebattement, that all we have to do is to find true length. So we get an edge view. So if we take for instance this edge view here, we will be able to then rotate our measurements down onto our plan surface and look straight down on them. So if we rotate our measurements down and look from plan, we will be given the true shape of our surface. And this is the same for all elements of this, like so. There's a useful resource, and the pupils can also create their own smaller model to have at home, so they can complete questions and to also self-assess their methods and to ensure they're on the right track and to develop engagement with the topic.